So now we are going to look at the section that we'll be spending the most time on, and that is the process emissions, because this is where the calculations happen. This is where we put all of the final information in so that we can get to the emissions for each one of the unit processes. So let's click on the Process Emissions tab, and let's immediately go to the natural gas boiler. Keep in mind, we are going to go through each one of these because each one illustrates a different process. And what we were trying to do was really get a good cross-section. That's why we have boilers, we have internal combustion engines, roads, piles, tanks, non-road tailpipe, and paint booth. Is we wanted to really get a good cross-section to show as many processes as possible. So let's start with the boiler. We'll click on the boiler. There are three tabs you will see at the top: Process, Operations, and Emissions. On the Process tab, you will see that there is a throughput and the throughput units. For this particular boiler, we chose to stay with million cubic feet of natural gas burned. And in this particular example, we're saying that 25 million cubic feet of natural gas was burned in this natural gas boiler. If we scroll down further, you'll see these boxes. They're all empty right now, but we're going to get to these. Supplemental calculation parameters. If any of these parameters were necessary for the calculation of the emissions, we'd be required to fill them out. In this particular instance, we're not. When we get to some of the other examples, we will be. Keep that in mind as we go forward. Operations. This is where we put in the operating hours. As we look at this, standard start time is a drop box. We could change that to 7:30 a.m. and we could say, no, we operate till 5:30 p.m. Something to note is this will automatically calculate for you. Once you've chosen the hours per day and days per week, it will begin to automatically calculate for you. So I'm going to illustrate that. We'll delete the hours per year, the days per year, the weeks per year. And we'll start at the hours per day. We'll say we operate 8 hours a day, 5 days a week, 50 weeks a year, and you can see that the actual days per year and the actual hours per year automatically filled. And something to remember with this is that the days per year and the hours per year must be within 10%, plus or minus 10% of the calculated value. As we look at the monthly operating percentages, in this particular example, we are saying that it operates evenly throughout the year. And the way that we got to these operating percentages for each month was we took the number of days in that month and divided it by 365. If you have a process that operates evenly through the year, we have provided, if you click on this little green question box, it will automatically open up a tab for you and show you what the percentages would be if you're operating evenly throughout the year. So we will come back to the operations, and we now feel good with the updates that we've made, and we will come to the emissions. What we have right now is one of the most straightforward examples, which is using AP42 emission factors that are already in the SLEIS online submittal system, and so they will populate. If we look and we say, okay, well, we have the options of calculation method code. If we click on that, you can see that it's an extensive list. Everything from CEMS to EPA emission factors, engineering judgment, material balance, site-specific, stack test, and vendor provided. As we look at this, we've chosen 8_2. 8_2 is an EPA wet-fire emission factor pre-control. So before control, this is the emission factor. If we were to click on this little calculation button right here, it will display the factor that is an option. So wet-fire uncontrolled emission factor of 7.6 pounds per million cubic feet. We'll select it, and it will automatically calculate for us. In this particular example, we used that same estimate code for everything except for the NOx. We previously had listed that we were using a low NOx burner. Because we listed that we are using a low NOx burner, it will now display and give the option for the emission factors for a low NOx burner, and there are two of them. 50 pounds per million cubic feet, 32 pounds per million cubic feet. In this example, we're saying that the emission factor that we're going to use is 50 pounds per million cubic feet, and I will select that. If we had not attached a low NOx burner to this boiler earlier, that emission factor would not have been made available. But because we did, it was made available, and therefore we were able to select it and use it in the calculation. So we see now that the calculations and the emissions for this particular boiler are all here, including some of the HAPs, the benzene, the formaldehyde, and the hexane. So when I hit save, it successfully saves. But let's say that you realize, oh no, we didn't have 25 million cubic feet. We actually burned 32 million cubic feet of natural gas. So I key in 32 million cubic feet of natural gas. I come to the emissions, and now I'm going to say calculate all. I'm going to click on this button. What you'll want to pay attention to are these estimated emissions over here to the right, because they'll change when I hit calculate all. And you can see that they calculated and that they updated. All we had to do was change the throughput and then hit calculate all, and it updated the estimated emissions. And now I can hit save again, and it's successfully saved. So we will go back to the next process, which is the diesel portion of this boiler. As you can see, the diesel portion of the boiler, we're using 1,000 gallons of throughput. So we're saying that we burned 10,000 gallons of diesel fuel in the boiler. And you can see that we have now, in the supplemental calculation parameters, filled out the sulfur. As we come over to the operations, we can leave this the same, or we can update it as we did for the natural gas portion, but let's leave this the same, and let's go to the emissions. And as you can see, everything is 8_2 for the calculation method code, which is an EPA wet-fire emission factor pre-control. But I want to look at the SO2, and I want to click on the factor formula button. This pops up this box. And as you can see, in order to use this factor or formula, we need to have the sulfur listed. We did earlier, so when I click on this and say select, it will perform the calculation. But as an example, let's come back to the process tab and let's delete the sulfur. So we've deleted the percent sulfur, and we're going to come back now to the emissions, and I will click on the display, the factor formula, and I'll select it again. And this time we get an error, and it shows us that we have a problem. At the top of the page, it says that the formula is 142 times the sulfur, the field is percent sulfur, and it needs to be a valid number. You can see over on the Process tab, there is the yellow triangle with the exclamation point in it, showing that's where the issue is. I click on that, and it's highlighted, the percent sulfur box. So I know I need to fill that out, 0.05. I put that in, I come back to the Emissions tab now. I click on the Display Factor Formula. I select it, and now it calculates. So I can say Save, and we successfully saved. But just as we did with the natural gas boiler, if we look over here on the Process tab, we say, no, it was actually 15,000 gallons. And the sulfur was actually 0.15. And we come back over to the Emissions tab and we click on Calculate All. You'll see that the emissions all updated accordingly using the new data. So we'll click Save again. It's successfully saved, and now we can go back. The next process that we're going to look at is the natural gas internal combustion engine. Something that I want to point out here is that the throughput units are in million BTUs. Now, if you look at this particular SCC, 202-00252, it's an internal combustion engine, industrial, natural gas, 2-cycle lean burn. It's a commonly used SCC by many facilities when estimating the emissions for a natural gas internal combustion engine. It's important that the throughput units match the emission factor units, and we're going to look at that now. If we look on the Emissions tab, the emission factor unit of measure is million BTU as well. If our intention is to use the pounds per million BTU emission factors, then the throughput units must match and also be in million BTU. So we come to the Emissions tab, and we can see that the emission factor unit of measure is all pound per million BTU. However, unlike the previous examples with the boiler, we're not using exclusively the 8_2, which is an EPA web-fire emission factor. We're also, in this example, going to illustrate the use of CEMS data. As we look at this, we are going to be using CEMS data for the PM10 primary, PM10 filterable, PM2.5 primary, PM2.5 filterable, and the PM condensable. For the remaining emission factors, we will be using the EPA emission factors as they are listed in the EPA web-fire emission factor table. So let's click on PM10 primary. In the drop-down, we chose 1_1 CEMS post-control emission factor, and we listed the emission factor units in million BTUs. So they match the throughput unit, therefore it will calculate. If we wanted to update this, we could. We could say that this is 0.006 and then click on the Calculate button and it will update. But we felt good with the 0.003, so I will hit the Calculate button again and it will change it back. So this is an illustration of using the CEMS calculation method code for the PM10 primary, PM10 filterable, PM2.5 primary, PM2.5 filterable, and the PM condensable. The remainder of the emission factors are from the web-fire table, and that is all that we are going to illustrate for this particular process. The operations, we set it up so that the operations for this particular example are 24 hours a day, 7 days a week, 52 weeks a year, 365 days, and 8,760 hours per year. So let's go to the next process. The next process is going to be the internal combustion engine for diesel. And as we look at that, we selected a throughput of horsepower hour, commonly used by many facilities in estimating their emissions, rather than using the gallons of diesel burned or the million BTUs. Many facilities use the horsepower hour. We put the throughput as 2,190,000 horsepower hour. The operations, we put 12 hours a day, 7 days a week, 52 weeks a year, 365 days a year for 4,380 hours. Basically, we were operating half of the time during the year. We come to the emissions tab, and you can see that we are using many of the emission factors from the WebFire table, and they are in the units of horsepower hour. So the emission factor unit of measure is pound per horsepower hour. There are a couple of things I want to illustrate with this because so many facilities use these emission factors from AP 42, and therefore they will be in the EPA WebFire emission factor table. There are no emission factors for PM10 filterable, PM2.5 filterable, and PM condensable listed in AP 42. All that is listed is the PM10 primary and the PM2.5 primary. Therefore, for facilities using these emission factors, you will only be able to list the PM10 primary and the PM2.5 primary. As we look at the NOx and the estimate for it, we can see that we are using something different as well. We're using a stack test, and we're not using the throughput unit of measure. We're using hours instead. As we illustrate this, it shows that there is a different way that we can estimate the emissions. Many facilities have stack tests, so what we've listed is 7.5 pounds per hour. Now the hours that are being used in this calculation are on the operations tab. This 4,380 hours are being used to calculate the NOx on this emissions tab in conjunction with the 7.5 pounds per hour emission factor that was derived from a stack test. Now, when using a stack test, it is necessary and required that the stack test date be listed. If we were to take that and delete it and then try to save right now, you will see that it will not let us save. It will say that there's a validation error and that we need to correct the issue, and it lists that the process emission stack test date is required. We will put in a new stack test date, so I'll go back and say, well, the stack test date that we wanted to put in was October 7th of 2017. Now when I click on the save button, it will save. So that is illustrating how you can use a stack test. And you can use the pounds per hour, and it will calculate using the hours off the operations tab, or we could have kept it in the same units of horsepower hour. If you have your stack test in those units, you could have listed it that way and it would have calculated as well. So I will now go back, and we are going to go to the next process, which is going to be the unpaved roads. So now we are looking at unpaved roads, but we will also illustrate how you can calculate paved roads as well. We have listed that the annual throughput for this particular process is 25,000 miles. As we scroll down, we will also see that we have a silt percentage, the mean vehicle weight, and the precipitation days. These are the calculation parameters that we've listed that will be necessary as we go to the emissions tab. The operations, we listed that this particular process operates about 8 hours a day, 5 days a week, for 2,080 hours a year. As we come to the emissions tab, you can see that we have the PM10 primary, PM10 filterable, PM 2.5 primary, and PM 2.5 filterable listed. The PM10 primary, in this particular example, because it's dust, the PM10 primary equals the PM10 filterable. And we would like facilities to list both of them, both the PM10 primary and the PM10 filterable, as well as when listing the PM25, we would like and request the facilities to list the PM 2.5 primary and the PM 2.5 filterable. So as we look at this, you can see that the calculation has occurred, but you can also see that there's a control efficiency that's being used. When we were in the control tab earlier in the demonstration, we had listed that there was a control efficiency for the roads of 75%. And we're going to go further in this demonstration with this, but first we're going to recalculate by clicking on the display factor formula button, and what happens is a box comes up and there are 3 options given. If you mouse over the notes for any of the 3 options, it will give a further explanation. The top option is that this is for paved roads. If we mouse over the second option, it's for unpaved roads, industrial sites. And the third option, if we mouse over the notes, it says unpaved roads, publicly accessible roads. These are the 3 different road types that you can select from. For this demonstration, we selected the unpaved roads, industrial, and now we say select. You can see that it calculated, but that it also lists the entire formula underneath the calculation that just occurred, so that you can see the exact formula that was used. Now this is the formula that is listed in AP 42 and is now therefore being listed in the WebFire table and being made available. The 75% control was used in the calculation because we selected as the method code the EPA WebFire emission factor pre-control. By selecting pre-control, it then applies the control efficiency that we specified earlier. There are a number of SEC codes that will enable this feature to be used, meaning that if you have a road and you want to estimate the emissions of dust from the road, there are a number of SECs that have been designated and are therefore available and will enable the selection of these formulas. We have put on the website a spreadsheet that lists the various SEC codes that can be used to enable the selection of the roads formula. I'm going to illustrate something by going back a few steps, and you can see that the overall control efficiency is 75%, and that right now the PM10 primary and the PM10 filterable is about 4.95 tons per year. But let's go back. Let's try something. If we go back all the way back to the control devices and we look at this dust suppression of unpaved roads, I click on it and I say, well, we're really only controlling 50%. And I click on save. It's now updated that. We're going to come back to the process emissions. We're going to come back to the unpaved roads and to the emissions. And now I'm going to say calculate all. And as you can see, all of the emissions just went up. The emissions all just went up because there was a lower control efficiency now associated. And you can see the 50% that we just keyed in the control tab is now being listed here and being incorporated into the calculation. We'll move on to the piles. And the piles are using the formula from AP42, and that will be made available for calculation. If we look at the supplemental calculation parameters, you can see that we have moisture listed and wind speed listed. But as an example, let's just delete the moisture. We'll look at the operations. We feel good with the operating hours. We come over to the emissions. I open up each one of these. We have the PM10 primary and PM10 filterable, the PM2.5 primary, the PM2.5 filterable. And I'm going to click on the display factor formula, and I'm going to select this formula right here, which is the formula coming from AP42. When I select it, it gives me an error, and it says something is missing. It's the percent moisture, and it shows me I need to go back to the process tab, and I need to put in the moisture. So we do need the moisture percent keyed in, and then when we come back to the emissions tab and I click on the display factor formula and I select, it will now calculate. As you can see, the control efficiency of 75% is being listed, and it is being incorporated into this calculation as well. When we select the display factor formula and we select it, it is listed underneath the calculation, you can see. And this is the exact formula that is coming from AP42. So we will go back now and we will look at the crusher. There is something I want to illustrate with the crusher. We are showing that we have 50,000 tons of material going through the crusher. Earlier, when we were going through the control section, and I'm going to go back now to the control section, we were controlling the crusher with wet suppression. I'm going to go back and illustrate this. We go back and back again. We can see the control devices tab. I'm going to click on that. And here we have wet suppression of crusher. You can see right here. The control measure is wet suppression of crusher. That's important because now that we are in the process emissions and we're going to estimate the emission, we want to use what is a controlled emission factor. And if you look, when I click on the calculation method, we are now using A_1, which is an EPA web fire emission factor, post-control, meaning this is a controlled emission factor. If we had not selected the wet suppression, it would not make this available. But because we did, and I click on the display factor formula, it now gives me the option of using the controlled emission factor that comes from AP42, section 11.19.2. And as you can see, there are two options here. One is for crushing, and the second is for screening. But we're working with crushing, so we're going to select the top one. And now it will use the controlled emission factor of 0.00054 pounds per ton. What we don't see down here is the control efficiency that we listed over on the control devices section. The reason for this is because we are using a controlled emission factor. We are not using an uncontrolled emission factor and then applying the control. So because we are using this factor of 0.00054 pounds per ton, that's a controlled emission factor, and because it's already being controlled, it does not list the control efficiency here. If it did, it would indicate that it was using that control efficiency, but it's not. It's using a controlled emission factor instead. So that is how you would use a controlled emission factor from WebFire and AP42. So we will move on now. We're going to go to the paint booth. The paint booth illustrates mass balance. We are saying in this particular example that we had 10,000 gallons of paint that was used in this particular process. As you can see down in the supplemental calculation parameters, we have indicated that the percent VOC was 75% and the density of the paint was 5.5 pounds per gallon. Our operations were 8 hours a day, 5 days a week, 50 weeks a year for a total of 2,000 hours a year. When we come to the emissions, what we're looking at are the VOCs and some additional hazardous air pollutants. So as we look at the VOC, I'll click on it, and I am going to click on the Display Factor Formula button, and it brings up the factor or formula, which is the mass balance, density times the VOC over 100. We're going to select that, and it will perform the calculation. But let's say that we realized that the density was actually 7.5 pounds per gallon. We come back to the emissions. We choose the mass balance again. I click select, and it updates the emissions now. What we can see is that the control efficiency is being used in this calculation, the afterburner that we had selected and attached to this process in the control devices section. As we look at the hazardous air pollutants, we can see that we have benzene, toluene, and xylene, but what we've selected is mass balance no emission factor, 3_0, which does not allow for the entering of an emission factor because we've indicated there is no emission factor. We're just keying in the overall tons that were calculated outside of the system. So for this particular example, 0.125 tons of benzene, 0.05 tons of toluene, and 0.075 tons of xylene. So if you have emissions that you're calculating outside the system, you can key them in and not put in an emission factor. You can do that for any of the calculation method codes. If you were going to do that for CEMS, it would be 1_0. For engineering judgment, it would be 2_0, and so forth. You would key in just the emissions themselves in tons per year. For this particular example, we have 3_0, which is material balance, no emission factor. We just keyed in the tons of the benzene, the toluene, and the xylene. We will now go through the calculation for non-road tailpipe emissions. What we decided to do was incorporate emission factors from EPA's non-road mobile model into the SLEIS online submittal system so that the emission factors would be available to the facility. There are two ways that you can use these emission factors. One is you can use the gallons to calculate it, or you can use the hours that the vehicles operated. Right now we're showing that it was gallons that were used, but we're going to change this in just a moment. If we look at the operations, we can say that, well, for these vehicles, they operated on average about 12 hours a day, 5 days a week, 50 weeks a year for about 3,000 hours per year. But we actually have 5 vehicles. So the overall operating hours were actually 15,000 hours per year. And in this case, we will calculate using hours, but the hours being used to calculate will come from this process page and from this throughput of 15,000 hours rather than the operations tab where it lists 3,000 hours. So on the process tab, we have listed 15,000 hours that these vehicles operated, and we will come to the emissions page. And we can see that we have PM10 primary, PM2.5 primary, SO2, NOx, VOC, and CO. This is another instance where we will only be calculating the PM10 primary and the PM2.5 primary. We will not be calculating the filterable or the condensable. So we will calculate these by selecting the method code, and the method code is going to be 8_2, and it will bring up the emission factor in pounds per hour. I will select it, and we will do this for each pollutant. And I'll click on Save. And it has saved it now. So we just calculated using 15,000 hours of throughput and the emission factors in pounds per hour that come from the SLEIS online submittal system, and these emission factors originated in the EPA Nonroad mobile model, and we incorporated them in the system. As you can see, the SEC code for this particular Nonroad tailpipe process is 10 digits long, and it's important to select the proper SEC code for a couple of reasons. The first is, in order to have access to the emission factors that are contained within the SLEIS online submittal system, you need to select a proper Nonroad tailpipe SEC. The second reason is that Nonroad tailpipe emissions are not chargeable, and this is how we are able to separate the emissions that are Nonroad tailpipe from the emissions that are not. So it is important to select a proper Nonroad tailpipe SCC when estimating Nonroad tailpipe emissions. We have listed on our website a spreadsheet that contains all of the valid Nonroad tailpipe SCCs. We will now illustrate tanks. Many facilities have fuel tanks. Some facilities have many fuel tanks. As you can see, we have an annual throughput for this particular tank of 35,000 gallons. Operations are 24 hours a day, 7 days a week, 52 weeks a year, 365 days, and 8,760 hours, operating evenly throughout the year. As we click on the emissions, we see that we have VOC, benzene, ethylbenzene, toluene, xylenes. We use these as examples. But we can see that we used 8_0 as the calculation method code, which is EPA, no emission factor, meaning you will just list the tons per year of the emissions. And we did that for each of the pollutants. We did that for VOC, for the benzene, the ethylbenzene, the toluene, and the xylene. We understand that most facilities will use EPA tanks in order to estimate the emissions of VOC and hazardous air pollutants, and that there are facilities that have specific programs that will estimate these emissions as well. So this is how we have envisioned many facilities listing their emissions of VOCs as well as hazardous air pollutants for tanks.